Hello students, good morning. How are you doing? Are you having a great day? Today we'll be dealing with chapter 15. The topic is Spectra. That has to do with formation of colors from the word spectrum. Let's start. Dispersion of light. For us to be able to define the dispersion of light, we are going to drag the following words into the correct boxes. When white light passes through glass, okay, it retracts, that is a prism. As it enters and leaves the glass, and it splits into spectrum of colors. Colors are not of equal width in the spectrum. A rainbow is a naturally occurring spectrum. White light from the sun is split up into a spectrum of colors as it enters and leaves droplets of water in the air. It is also reflected back to the viewer by total internal reflection. The splitting of white light into a spectrum is known as dispersion. White light is a mixture of all the different colors of the spectrum. So we check. That's correct. So we also define the dispersion of light by filling in the missing words. So we want to find out what happens in a prism to produce a spectrum. As white light enters a prism, it slows down. The white light is refracted and its direction changes. Okay? Now, dispersion occurs because each color is refracted by a different amount. Violet slows down the most, and so it is refracted the most. Red light is the least affected. So we check. That's correct. Now, images describing the spectrum and the dispersion of white light. Let's say, for instance, in this left diagram, we have that light is coming out from a specific place. By the time it moves through the air, you will now have it displaying different colors of the rainbow. We have red, orange, yellow, green, blue, indigo, and violet. Those are the colors that will emanate from the dispersion of what? White light. But in practical terms, when you get to the laboratory, the prism is used for the dispersion of white light. When you pass a torch, you light it towards a prism or light, it gets to the what? Prism. And by the time it is going to be refracted out of the prism, it separates into different colors. Though these different colors have the same speed, but different frequencies, and also there will be different wavelengths. So let's continue. The electromagnetic spectrum. For us to define it also, we drag the words into the correct boxes. The sun is a star. The sun's light is shone on a prism to produce a spectrum. Then a thermometer is placed at different points in the spectrum. The reading on the thermometer rises because objects get warm when they absorb light. The thermometer reading grew higher towards the red end of the spectrum. To move beyond the end of the spectrum, the reading became higher. This led to an invisible form of radiation, which is called infrared radiation. Infrared radiation is experienced through heat radiation. It is always received from the sun. This heat or radiation behaves similar to light. Let's take, for instance, you place a kettle of water on your gas cylinder, and the gas cylinder is being lighted, and by the time the water begins to boil, the heat you feel from the gas cylinder towards the kettle is the type that we call infrared what? Radiation. So it brings what? Heat. And don't forget that heat is a form of what? A wasted energy. So we check. That's correct. So beyond the violet, that is, if you should have the spectrum of colors, we have red, orange, green, red, orange, yellow, green, blue, indigo, and violet. What happens beyond the violet region? So let's do that now by filling in the missing words. Silver salts are blackened by the exposure to sunlight. A spectrum of sunlight is directed to a paper strip in silver chloride solution. The paper became blackened. The effect was strongest beyond the violet end of the visible spectrum. This is known as ultraviolet radiation. The eyes cannot detect ultraviolet radiation, but sensitive photographic film can. Both ultraviolet and infrared radiation were discovered by looking at the spectrum of light from the sun. There is a connection between infrared, visible, and ultraviolet radiations. A cool object emits radiation at the cool end of the spectrum. The hotter the object, the more radiation it emits from the outer end. We check. That's awesome. Now, let's go back to electromagnetic radiation. So we fill the correct words into the correct boxes. Now, for now, we discuss about the wave model of light. Light is another form of wave. Light also has different colors according to its frequency. Red light has a lower frequency than violet light. Visible light occurs as a spectrum of colors depending on its frequency. Light is a small oscillation in electric and magnetic fields or electromagnetic waves, which could come at any value for frequency. All electromagnetic waves travel at the same speed in empty space or vacuum, that is at the speed of light. Where you see that C indicates the speed of light, and that is 3.0 times 10 raised to the power 8 meter per second approximately. Like light, the speed of electromagnetic wave depends on the speed at which they are traveling. They travel fastest via a vacuum. We check. That's correct. Now, still dealing with electromagnetic spectrum, let's fill the words into the correct boxes. In there with wavelength and frequency. Red light has a greater wavelength than violet light. There is a greater distance from one wave crest to the next. Red and violet travels with the same speed, but red light has a frequency smaller than that of violet light. We can make up visible light has very high frequency, and that frequency is 10 raised to the power 14 hertz. So we check. That's correct. Now, looking at these two diagrams, we have wavelength and we have the wave still moving from left to right, but it's typically spreading out, have a large amplitude. But if you look at the wavelength, as you hear with figure B, it has a small amplitude or wavelength. So we are to fill in the missing words. Now, laser light is not dispersed by a prism. It is refracted so that it changes direction, but not split up into a spectrum. It is a light of single spectrum, that is monochromatic. Monochromatic light is a light of one frequency. So let's check. That's correct. Now, let's deal with this past question. One of these does not apply to the use of electromagnetic waves. Now, radio waves are used to broadcast radio and television signals. Yes. Infrared is used in remote control for devices such as TV and video recorders. Yes. Microwaves are used to transmit mobile phone signals. That's yes. X-rays are not used to check the internal organs of a body. That is false. X-ray also is part of electromagnetic waves, but it's used in checking the organs of the body. But the now said does not apply. That means this last statement here is false. So that will be the answer. We pick it now. That's the answer. So, what are the things associated with electromagnetic hazards? All types of radiation can be hazardous, that is deadly or lethal. So, telephone engineers must take care not to expose themselves to microwaves when they are working on the mast of a mobile phone. Domestic microwaves must be checked so that no radiation is leaking out. People who work with X-ray must minimize their exposure. Enclose the instrument in a metal case to minimize exposure and absorb X-rays. Now, looking at this diagram, you have white light entering into the prism and it is being dispersed, undergoing the white light undergoes dispersion. You can see here you have colored light. Now, don't forget that those colored lights are divided into 6 or 7. That is red, orange, yellow, green, blue, and violet. One of the effects of passing a ray of white light through a prism is to split the light into colors. What is the name given to this effect? That effect is what? That's dispersion. So we check. That's awesome. Now, which of the following is correct about the speed of electromagnetic wave in a vacuum? Don't forget that in a vacuum, the electromagnetic waves have the same what? Speed, but different frequencies and what? Wavelength. All of the electromagnetic waves. So let's see the options that we have. Infrared waves have the greatest speed. That is false. Visible light waves have the greatest speed. That is false. All electromagnetic waves have the same speed. That's correct. Ultraviolet light waves have the greatest speed. That is false. So all electromagnetic waves have the same speed. Now we are to choose the correct statement out of these three. No electromagnetic wave is a transverse wave. That is false. All electromagnetic waves are longitudinal waves. That is false. Only sound waves are longitudinal wave. So all electromagnetic waves are transverse wave. And that is the third statement. So pick it and confirm. That is it. So let's check these three statements also to pick the correct statement. During the dispersion of white light, colors produced have the same speed. Is that true? Let's continue. The splitting of white light into a spectrum is called refraction. That is false. That should be dispersion. Now, the next statement. During the dispersion of white light, each color is refracted by the same amount. Is that true? That is false. So during the dispersion of white light, colors produced are the same speed. So we pick that is correct. So with this, we've come to the end of this session. Do well to check our website www.edubbey.com for more of our interactive notes and videos. Bye for now.